Thanks everyone for joining PyDataTNT's second PyData meetup. We had our first one last January, a month ago. Now our speaker today is Nidia Sahjara. So before Nidia begins her talk, I just need to read out the PyData NumFocus Code of Conduct, which I'll just quickly paraphrase. Basically, be kind to everyone, don't insult anyone, behave professionally, and stay away or refrain from harassment, whether it be sexist, racist, or exclusionary jokes. None of those things are welcome on this meetup group here. And basically, just remember, not everyone here is going to be a Python expert, but everyone should behave like professional, and it's going to have many people of different backgrounds and languages. So just bear with us if that is the case here. But regardless, we're an inclusive community and a harassment-free community. So regardless of your gender, sexual orientation, identity, expression, physical appearance, body size, race, religion, we accept everyone and we do not tolerate any harassment. So thank you, and hopefully this will be a friendly meetup for all. So now, Nidia, if you could share your screen, you can begin your presentation.
Okay, great. Thank you, Rajiv. Okay, is everyone seeing properly?
Yeah, looks nice.
Seeing it, okay. Loving it.
Yeah. It's as close as we can get to the stage today. Okay, so thank you for joining, everyone. On behalf of PyDataTT, we will be presenting a Carnival edition. The whole focus would be to generate Soca and Soca-Parang lyrics, and then to assess these lyrics based on elements of creativity, all using Python. So generally, the outline of this, not everything is here, but the general outline of it is that keep in mind that language is not text-driven, but speech-driven. So that's sort of the foundation of what we're doing here today. So it's not just what we say, but it's how we say it. So in natural language processing, we usually use information retrieval, and that comes in handy when it comes to extracting elements for financial data, for instance, when we look at pulling out information from news articles, speeches, social media, for instance. But when it comes to music informational retrieval, it's a bit different. It's very different, actually, because think of it more like poetry. And then while you're keeping MIR in mind, then we have to get into, when we create our lyrics, how to think about that, how to understand the difference between MIR and regular IR in natural language processing. Then we're going to discuss prosodic challenges, generally ambiguity, which is a big problem when it comes to the human versus the machine in creating text. And then we're also going to look at the similarities between the human and GPT-2. Now, GPT-2 is basically the transformer that we use to generate our lyrics. I'll get a bit more into that later on. And so we'll take a look at the lyrics that we generated, and then we'll find a way to identify quantifiable aspects of creativity using Python. So MIR, like I just explained, now without proper information retrieval in text, you will have a loss of information. When it comes to hacking, security, and stuff like that, we have our ways of looking and going through, for instance, even credit card fraud. And you go through to find that information, so you don't want to lose that information. We don't want to lose information for another reason with music. So when you look at music lyrics, it has spoken features. What I mean by spoken features is that there are other forms of info that can be lost, and written text treats words as the basic building blocks of language, like I just mentioned. But now when we have the spoken language treats syllables as the basic building block. And I will get into this a bit later on, but not too much, but on your own, you can look at it a bit more when it comes to syllables and pronunciation with regard to how we speak. That's another part of linguistics, that it's a separate study a separate field of study to natural language processing, but natural language processing is highly built upon linguistic concepts. And so NLP begins its analysis with written text. So it's important, if you want to get into the domain of natural language processing, to have a better idea of the related fields such as linguistics. GPT-2, as I mentioned, is the language-based model that we use to generate our lyrics. In essence, we used GPT-2 Simple, and the really simple way to look at it without getting confused at all it's doing is that it's predicting the next word given the previous words in a bunch of text. And that bunch of text is our lyrics compilation. Our lyrics compilation for the Soca was a few hundred songs that put together by scraping. And I'll show you my scraper pretty soon. It's very short and very simple. So we trained this on a data set of 8 million web pages. And it's free to access because it was part of a research project. And even though we used the smallest model, it's actually pretty large, of 500 megabytes. And we fine-tuned with our custom data on 2 different models, the Soca-Parang and the Soca songs. Now, keep in mind the Turing test. You want to know who wrote something when you look at it. Was it the machine or was it the computer? So how does the human judge differentiate if it's written by the robot or a human, or not even that? Even a step further, how would you know that something was poorly written, as in poorly composed? Because I'm pretty sure if I were to make up a poem or a song, it would pretty much sound as if a 5-year-old did it. So we know that it's not written by a human or it's not written well, but why exactly is that? And these components, these elements are actually quantifiable. So before we get into, stepping a bit further into it, I just want to give you an idea of some of the generated lyrics that was given to us by our model for the Soca-Parang. Now, if you see here, we have some mixed lyrics where it has some original content, and then original meaning the output was original output. And then we also had some mixed lyrics with repetitiveness from like copying from some of our previous songs. For instance, grab the cork and have the ball. This woman bring out a bottle, and this is clearly not making any sense, a number. So you notice here, it's not that good, but the Soca-Parang one was trained on such a small model that we expected it to be pretty bad. But this one here, I just wanted to show that it kept repeating a lot, like oi, 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 ay, ay, ay. And I'll show you why this is a bit important when it comes to flow and rhythm and a song being catchy. So when you look at lyrics, sometimes it looks, it doesn't look good. It looks sort of stupid sometimes. But when we actually listen to it, it's completely different. So when I mentioned the memorized lyrics is not so good, one of the reasons that GPT-2 is great because it's so powerful, but it's different because it has a bit of, it doesn't lose efficiency and energy. Think of it like that way. When it has to go back and do long-term thinking, that is what makes it so powerful. But because of that, it has a flow. We need to train it on a lot of songs, a lot of data. And basically memorizing the answers to a math quiz, and instead of knowing your formulas, is basically what I'm explaining to you now. That is how GPT-2 works without enough data. So that is why we moved on to Soca, as well as I think I sort of have a personal preference for Soca. And what I explained just now with the Soca-Parang having outputs that are too repetitive from our previous, the data that we used to feed our model, that's a form of overfitting. And we were able to reduce it because the Soca outputs actually had a lot of the verses that were mostly original. But here we actually had some memorized lines, because if you know that song by Marshall Montano, Dr. Mashup, we have a lot of the words here being repeated. But in this one, it's fairly original. This one actually, I thought it was pretty funny because, yeah, a lot of it is basically original, and there's actually even some rhymes going on. Well, the repetition, which is good for songwriting. But here we have "we on the road" driving. That should really be "we on the road" whining, or something along that, context. Actually, we should be doing that today. And so, yeah, so like I said, when you generate lyrics, it doesn't just have to rhyme, or it just doesn't just have to flow. It has to make sense. So that brings us to the identify the creativity parts of it. And the reason I'm speaking about this at length is because whether you want to work in music, something with creativity, or finance, or security, politics, you need to understand your domain. That domain familiarity is very important career-wise. And so in this case, we need to think like a songwriter if you want to get into NLP or assessing a song's potential for being catchy. So how do we think like a songwriter? We can create neural networks or perform fine-tuning, which is what we did with our GPT-2 model, to count or mimic rhythmic lyrics and poems. That's actually what we're doing. But we want to know, how can we do that? So the creativity comes from unusual usage of words through effects such as alliteration, assonance, and elison. But we'll get back to these three shortly, and I'll explain each one with examples. And just want to get to this part. This is really important when it comes to songwriting and also poetry writing, prosody. And I mentioned this spoken feature earlier. An example of it now, when you look at poetry, prosody refers to the study of poetic meters. Yeah, that's actually how we can have a gauge for rhythm. So that poetic meters, that study in prosody, that is essentially rhythm in words. We're not thinking melody here. We're thinking just with the words. And so the prosody is the rhythm, stress, and intonation of connected speech, as opposed to smaller elements like syllables of words. Now, prosody can reflect double entendre, irony, sarcasm, and by the way, this whole double meaning thing is really important in soca music and Soca-Parang, because that's a big reason why it's so enjoyable. There's so much comedy in them, or subtlety, that adds to the creativity element that is so difficult for a machine to be able to mimic, as opposed to a human. So that's one of the challenges that it has when it comes to computer-generated text. And when it comes to the ambiguity, this is one of the biggest challenges you will find, because you need ambiguity. It's not that we don't want it. We want it, but it needs to make sense. Now, like I mentioned, we combine natural language processing with computational linguistics and psycholinguistics. And this combines in a way for us to understand ambiguity, because it's actually something that they study in psycholinguistics when it comes to globally ambiguous relative clause sentences. Basically, I'll give you an example instead of just explaining it now. So the challenge that AI faces is that we need to balance this ambiguity with creativity, with grammar that makes sense. And after going over this and performing this study, it really would teach you to appreciate what our artists and lyric composers actually do. One example that they study in psycholinguistics is this sentence: "The maid of the princess who scratched herself in public was terribly humiliated." You can look at the first clause, the maid, and the second clause, princess, and they are both correct when the case where who really got scratched. That's an example of ambiguity, and both are not wrong, but it's part of the long-term way you access memory. And the reason I'm bringing it up is that GPT-2 works in that sense, where treats each word separately, but it has the ability to think long term from before and relate it to the word over here. Other models, a lot of the not as powerful models don't do that. An example here, one of the most popular Soca-Parang songs is by this guy, Kenny G, the Paintbrush song. And he says in the lyrics, grandkids ready to go out, still have to go and shop. This is an example of ambiguity, but at the same time, it adds creativity. It adds likeness to the song. It's more likable because who is it that's ready to go out? Is it the grandkids or is it me? Both are correct if you understand it that way. But if you were to say grandkids ready to go out, but they still have to go and shop, it sort of kills the flow. These are some of the things we're not even aware of, but it adds the creativity and the flow and the poeticness to the song, or should I say the prosody. If you want to learn more about the psycholinguistics part, because it's actually a deeper part of the psychology in it, in the way we think and relating it to GPT-2, you can always talk to me about it and email me and I can send you some research papers on it. Now let's go to the fun stuff. Now I mentioned alliteration before. It's used to create flow. And I'm hearing a loud noise somewhere. Yeah, so alliteration, why is a song catchy? So alliteration can make you get an idea of the emotional state the song should be or the energy levels the song should have. So Nyla Blackman's song, Soca, she says this quite a lot, ping pong, and she goes on, and it's quite frequent in the song. And if I'm reading this and want to extract information, if you use NLP, you can quite likely use these words would be deleted when you clean your text with NLP, considering all these garbage words or what we call in NLP stop words. But that's a big mistake when it comes to our song, because it's a key element in our song, because these repetition of the P and the same sounding P, because you can have P with a different pronunciation, but the P in each one, ping, pong, ping, and it gives you the idea of the motion of the guy's hands playing steel pan. It also gives you motion in how the words are flowing, because if you actually sing it out, it's catchy. And why is it catchy? So I have another example. And this one is, we're using Marshall Montano's Mr. Fat. And this song, Baby, the Sugar on Your Skin, the Sweetest Melanin, this is actually an example, well, two sentences here that have alliteration. You notice there are no obvious rhymes, but it's catchy. It's a lovely song. And this is actually a nice part of the song. And why is that? Because you'll never think, okay, there are no rhymes here. Maybe we shouldn't put it in the song. It's not going to sound good. But that S sound, sweet, sugar, but it's a softness on the S, and skin. That is an example of alliteration. And another example is that stop and stare. Then another example in the Mr. Killer's song is that, if you look at this, I love I love them fat girl because you thick and warm boy. But you notice that nothing is rhyming here. But if Mr. Killer sings this out, it's catchy. And that's because at the end of it, he adds the W, warm and boy. And if he sings that out and then continues singing, it adds that alliterative flow. And I'd like to show you an algorithm I wrote with a function to detect alliteration in Mr. Fat in that song. And you can use it for any other song you want. And not just one song, but you can do it for a range of songs and then rank them to suit. Forgive me for this. When I shared my screens got mixed up. Right, so if anybody wants more clarity or would like me to share these notebooks with them, please just ask me, and I definitely will. Now, in linguistics, there's something called phonemes, and that's basically how in each language we have different phonemes. And in English, for instance, we have CH gives you ch, and SH gives you sh. So the definition of a phoneme, and I just got this from Wikipedia, is a sound in a language that has its own distinct sound. So what I'm doing with this algorithm is that I'm setting the phonemes that I want, right? And then we're going to iterate. Now you can get adventurous with this. This is just a first step in creating a song alliteration detector or ranking. Phonemes, like I was showing you here, all we do is that you can set it to whatever phonemes you want. And this is just a short example. You can get quite adventurous and add your different phonemes to it. The reason you're setting this is that we're going to iterate through the song Mr. Fat. And when we iterate through it, we created the function to be able to see and pick up what extent we have alliteration in the song. And the reason you want to be able to do this is that in music production, you can put together a few different algorithms and actually multi-neural networks to be able to detect how likable a song is. And this is just one example of a factor to be considered. And if you look, just wanted to show you one other thing. Anyway, so when you go through the song, you can actually change the data set and put a bunch of songs and rank each song to see the type of alliteration it had, the number of alliterations, and then compare genres. Compare soca to rap, because rap is infamous for alliteration. I think Eminem is actually quite gifted when it comes to his natural ability to alliterate and some of the other creativity elements, which is why his rap is so popular. So we just did it on Mr. Fat, and the output of it was that of the entire song, the sentence with the most alliteration was the example that I showed you before, which is the sugar on your skin, the sweetest melanin. And of the entire song, the chorus is fast wine. He says that repeatedly, fast wine over and over. And basically, if you go through the song manually, which I did, it's actually correct. So the song alliteration detection, it works. It's just a nice, simple loop that I just wanted to show you and share with you. So let's go back to our main presentation. One moment, please. So that's it for alliteration and our example for the algorithm. I'll quickly go over assonance for you. I actually am a fan of assonance because we hear it all the time in music, and it's not an obvious rhyme. And it's amazing how when I looked at it, a lot of the soca music that I love, like beyond love, like quite a lot of it, I manually saw how much examples of assonance that we ended up having. So one of my all-time favorites is obviously Soca Kingdom. And if you look at it, one of the sentences that he says over and over and over is the whole of the kingdom come down. So what exactly is assonance? It's a shared vowel sound, but it's not just at the end, because usually when we rhyme stuff, we'll be like duck and truck, and that's a typical normal rhyme. But why is it that the whole of the kingdom come down is so catchy? You'd notice here that the O's in the middle has the same stressor, dumb, come down. So it sounds very different when we say the entire word, but the enunciation on that O is actually the same. And because it's three consecutive words, one after the other, it produces that rhythm rhyming. So in this case, with Baron's Christmas song, Quasi and Away, they're spelled very differently. So they don't have that phenome ending, but they do rhyme. But it's still less obvious that as opposed to this Kingdom Come Down example. And similarly to the alliteration example, with the alliteration, the function that we built, you can detect assonance, which is harder to detect, but it's still detectable. We're not that at where you want to be with NLP with this, but it's an idea of where you want to be when it comes to assessing songs and also written work, to assess your own AI-generated work and compare it to also human-written lyrics. Another example here. We start the carnival up and up, whine and follow the truck. This is actually part of our AI-generated text. And a lot of the AI-generated text for our soca music did not make sense. For instance, the "Let Us Go on the Road" driving. And some of it rhymed, but more in a very immature way, not a very proper song written likably, as opposed to not making much sense. But in this case, now we start the carnival up, whine and follow the truck. Now, up and truck, that does not rhyme. So why don't you use a word like duck instead of truck? But at the same time, it's catchy. Carnival up and up, whine and follow the truck. Why is that catchy? It is, and they don't rhyme. But if you look at you, up, and truck with the same you and you, that's an example of assonance. So these are quantifiable ways that we can be able to assess our creativity and catchiness and likableness of a song. The last one we're going to look at is Allison. And when you look at cliticization and connectivity in natural language processing, a clitic, for instance, when we do NLP work, one of the examples that we have to be aware of is that when we break apart our words in NLP processing and cleaning our information before we extract information, we actually would break this up and split it into two words, I am. So that's what we mean by a clitic. It's a way to expand and split these up into their actual words, into their actual tokens. In NLP, if you hear me use the word token a lot, it is just NLP jargon for word. So Allison is the removal of an unstressed syllable or consonant. And again, the basis for everything today is flow, or likableness with that rhythm in text without the melody. And so what does Allison have to do with this connectivity in how we speak and the speech and the text and how it goes with the song? So the removal of the stressed syllable, an example of what that is that, you see how this is joined here, the Y and the U, why you? Right, so when you're saying it, it's joined. Why you weeping? Why you crying? Why you bawling? And this is a song by Calypso Rose. And if you sing along with the lyrics, you realize how catchy it is. And it's really, really common in a lot of the really good popular songs. And actually a step further from this study I would like to do would be to take more popular songs and conduct some Allison or alliteration and rank them based on that, see how likable they are. And yeah, so there are so many examples of this in music. And while you listen to your songs from now on, I'm sure you're going to be wondering, this is Allison. It makes sense. This is why I like it so much. This was a little song my dad did for the presentation in December. And I know it's Carnival, but I'm just going to play it for you guys, because when we look at the lyrics, this is one of the computer-generated lyrics that we created for Soca-Parang in December. It doesn't make that much sense, but it's actually mostly original lyrics, and my dad put it into a song so we can, really see it work. So just have a look.
Hi, this is just one verse and the chorus, so I'll see what happened afterwards. Thank you.
So I'm sorry I don't have a soca version for you guys, but you never know. Maybe we can generate some lyrics that's good enough and we can get someone to sing it for us. So these are some of the resources that I've used from what I was citing, some of my ideas and content. And these are not all that I use, but you can always contact me if you want to read any of the research papers. So that's it for now. And feel free to not just ask questions now, but you can follow up with questions via email or even to the PyData group if you don't have my contact. And I will be happy to share and help as much as I can.
Very nice.
Yeah, very, very nice.